All right, ladies and gentlemen, today we will be going over a linear equations problem at the IB Math AISL level. So we have that the equation of L1 is this, ¿cierto? It is that L1 is y equals 5 over 2 x minus 12. See? So for part A, we need to write down the gradient of L1. Now, gradient, okay, is the same. It is the synonym of slope. See? Now, our linear equations can come always in three forms. See? They either give it to us in the linear equation form right here or in the standard form over there. See? Sometimes we have to create it ourselves with point slope form, right? Now your goal will always be to reach linear equation form here. See? Why? Because it is very easy to interpret. See? Once you reach this stage over there, m will always be actually your gradient or slope, and b is always going to be y-intercept. Okay? And so if we reach this form, it's very easy to interpret. So, have we reached this form over here? We have. They look awfully similar, don't they? So here we can immediately say, all right, for L1, the m is 5 over 2. So for part A, that's the answer. See? M1 for the first line is 5 over 2. See? All right, that's part A. Part B, they tell us the point A lines on L1 and has x coordinate 4. And we need to find the y coordinate of A. All right, so part B is a little more confusing. See, so they tell us that there's a point A, right, that has an x coordinate of 4 and some y coordinate. See, and so we need to find what that y coordinate may be. Now this point is part of this line here, right? And so what I can do is that I can plug in the information they give me of that point and see what the equation gives me. See, that's what I'm about to do. So I plug in, oh, y for y, of course, so that doesn't really change. Y equals 5 over 2 times 4 minus 12. All right, when we multiply fractions, we multiply straight across. So 5 times 4 is 20, divided by 2 minus 12. Y equals 10 minus 12. Y equals negative 2. This negative 2, this y equals negative 2, corresponds to this y here. So point A is actually 4 comma negative 2. See? Beautiful. That is part B. The y coordinate of A is equal to 2. Y equals negative 2. Finally, they tell us that the line L2 is perpendicular to L1 and intersects L1 when x equals 4. See? We are find the equation of L2, give your answer in the form blah blah blah, where a, b, and d are integers. Now, a couple things. We need to find the equation. See? Anytime you need to find or create an equation, I heavily suggest using point slope form. See? For point slope form, what do we need? We need a set of points and a slope. See? Those are the two things we need, right? And so, do we have the slope? Not yet. They tell us that the line L2 is perpendicular to L1. How did perpendicular lines look again? Let's draw one here. Perpendicular lines could be something like that. See? Now immediately you're probably thinking, so they're like opposites. That is correct. The mathy way to do it is that your first slope times your second slope has to be negative. Has to be negative 1. And so my first slope, we said, was 5 over 2. ¿Cierto? So I'm going to plug that in over here. 5 over 2 times m2, right? The slope of my second line has to be negative 1. I'm going to move some stuff around. I multiply by 2 everything, ¿cierto? So 5 times m2 equals negative 2. I divide by 5 now. m2 equals negative 2 over 5. So all I did here was get m2 alone. See, m2 is essentially a variable here. I'm trying to figure it out. See? So m2 is negative 2 over 5. That it? Now we need a point, right? We know that L2 intersects L1 when x equals 4. See? Now, when we say intersect, it means that it cuts the line somewhere. See? So they intersect right on that point. Why is this important? Well, that means that they share this point. See? And what do we know about this point? We know that this point is 4 comma something. Because it's when x is 4. Ahora, x being 4 sounds awfully familiar, doesn't it? Aha, point A. Point A has x equals 4. So y has to be -2. So this is a set of points that we can use as I mentioned up here. And this slope here that we discovered is right there. Why did we do all of that? Just to use point slope form. See? So the game plan is use point slope form and reach standard form. Reach standard form because it's what they ask us for. See? All right. That is the game plan. That is what we are about to do. See? So the set of points that I will use is 4, 2, -2, sorry. And the slope is -2 or 5. See? So y minus y1 equals m times x minus x1. I'm going to plug in my set of points, ¿cierto? We're going to have y minus minus 2 equals the slope, which we said was -2 over 5, times x minus 4. See? I make sure I don't mess up with the double negatives, which is why, by the way, it's useful to plug in with parentheses. Y plus 2 equals -2 over 5x plus 2 times 4, 8 over 5. See? Positive because it's a double negative. It's two negatives multiplying. See? All right. Awesome. Awesome. So now at this stage, I want to put everything over to one side. See? We're just going to throw everything to the left side because there's a plus 0 on the right side for what they're asking. See? So I'm going to do y plus 2 plus 2 over 5x, right? I did that by adding 2 over 5x to both sides, and minus 8 over 5 to both sides. See? All right. So now I have everything on the left side. I need to combine a couple like terms, and I have fractions going around. See? What I suggest is get that at this point, you get rid of the fractions because it's going to be easier to combine the like terms down the line. See? All right, so to get rid of the fractions, we need to notice that the denominator of both of them, luckily, is 5. See? So how do we get rid of this denominator being 5? Well, you multiply everything by 5. Literally. See? Whatever the denominator is, you just multiply by it to everything. So we're going to have y times 5 plus 2 times 5 plus 2 over 5 times 5 times x minus 8 over 5 times 5. And well, technically speaking, 0 times 5, but 0 times anything will stay at 0. Okay? All right. The magic that occurs here that is about to unfold is how the fractions disappear. See? So I'm actually going to analyze that. No. I'll just show you. See? All right. So y times 5, this first term here is just going to be 5y. 2 times 5 is going to be 10. And here, these 5's get rid of each other. See? And I actually end up with just 2x. These 5's again get rid of each other. And I end up with just minus 8. See? All of this equaling 0. I combine like terms. I'm not done yet. I end up with 2x plus 5y plus 2 equals 0. So now we are in this form here. See? Now, why did I have to get rid of the fractions? I should have mentioned this earlier. Oops. Because they're asking us for a, b, and d to be integers. See? Now, integers, the intuition is that integers, which is also written like this sometimes, in case it shows up, it's like a fancy z, is, or are, I should say, whole numbers. See? They're whole numbers, and they can be, that is a can, they can be positive or negative. See? So that is an integer. These are all integers, 2, 5, and 2. And that is how you solve this problem. The biggest hint I can give for any problem that is like this is reach the linear equation form, because from then on it's super easy to analyze or interpret. And make sure you have the tool of the point slope form, because it's your main way of creating equations, or linear equations, I should say. Ladies and gentlemen, that is how you solve this. I hope it helped.